Okay, we're going to look at some of these graphs because we're going to look at using division to find roots. And first thing we're going to do is kind of review matching up the factors with the x-intercepts. So when I look at number 1, it has some factors there. It has a 1 and it has a -2. So those are two potential factors for A. And if I notice, though, every single graph has that same pair of parentheses. So they're all going to have the 1 and the -2, 1 and -2, and so on every single graph. What's going to make it different is this factor they have divided out. There's another factor there, this x, that I could have brought over to this side and basically multiply by x, and a plain x is going to give me another factor of 0. If you've forgotten how I got these factors, remember I could take something like x minus 1 and set it equal to 0, and then I could add 1 to both sides and figure out that x was 1. So that is what I could be doing to get these x-intercepts, are these solutions. But for graph A, I'm looking for the graph that has a 1, a -2, and a 0 right at the origin. So the only one that touches the origin is F. So F is the graph that would match up with A. Okay, let's go ahead and try a different one. On the next one for B, I have a 1, I have a -2, and if I bring this over to the other side, I would have another factor of 1. Now this is a little special because I have two 1s, but one thing I can figure out from that is I will have a factor of +1 and -2, and that's it. So there are two graphs actually that have only factors of +1 and -2. They're graph C and graph E. To figure out which one the answer should be, it's actually going to be graph C, and here's how I know. It's graph C because since 1 shows up twice, I could basically write that as a x minus 1 squared and then an x plus 2. So I could write it sort of like that, x minus 1 squared and x plus 2. And since this has a square, this factor has a square, that's called a double root when the same solution shows up twice, and it makes it look kind of like a parabola right on that graph. So you can see where the x equals 1, you have a little parabola. That's because of your double root of 1 caused by the fact that that same factor showed up twice, so it had a square, kind of looks like a parabola. So that's how you can distinguish between graph C and E. When we go to equation C, I have the same thing I had earlier. I have a 1, a -2, and in this case, when I bring this over, I also have a -1. So the graph with a 1, a -2, and a -1 would be graph A. So C would go with A. Go ahead and pause your video and try the next three, and then we'll go over them very quickly. Okay, as we look at the rest of them, D, you could have had an answer of 1, -2, and +2. So 1, -2, and +2, which would look a lot like graph D because it is a 1, a -2, and a +2. When I look at E, that one would have been a 1, a -2, and another -2. So just like we talked about a double root for B, this one has a double root at -2, which means it will make a little parabola kind of looking like an x squared at -2. So that is what happens when you have a double root. It just comes up and touches on one side, then bounces back down and goes down. And that means, of course, F has to go with B, which makes sense because it should have roots of 1, -2, and 3, which B does. Hope you are able to understand how you can divide out these factors and zeros, and it's still making a solution whether it's multiplied or whether it's divided on the other side of the equation. That'll be very helpful for today's lesson.